so just to put it away, quick show of hands. Who was here last year? So for those of you who weren't here last year, I gave a talk last year. Stood out a bit compared to a lot of the others. And depending on your viewpoint, I gave the realistic view of formal. Others would say I perhaps gave the skeptical view of formal. And I ended my talk saying, I wonder if I'll have any friends to talk to at lunchtime. And I wonder when my friends at the EDA companies will be talking to me again. So I thought, if I was allowed back, I'd come back and tell you what happened next. And I was allowed back. The truth is that I had a lot of friends to talk to at lunchtime. It took 2 or 3 days before the EDA guys were talking to me again. And I had quite a bit of email traffic as well from people who'd listened on the web. And I think the realistic view is quite prevalent outside of groups like this. It was quite an interesting experience. But I thought I'd tell you a bit more about what we've done since we got home. Within my team, we've attempted to drive a formal initiative to adopt more formal tools. So I'm going to talk a little bit about what we did, some of the aims and targets of that. I'm going to talk about some stuff that we learned as we were going along, and then I'll take any questions at the end, or you can go and get a coffee from whichever. We're very early in our adoption of formal tools. So those of you who've been using formal tools for a long time can probably have a nap. You probably won't learn a lot. There's no rocket science in this. It's just our experiences. I have to put this particular slide up to be allowed to come and talk to you guys today. A little advert for Broadcom. For those of you who don't know, we're Broadcom in Cambridge. We are an IP and chip design centre. There's a couple of hundred of us so on that site, 150 odd software guys, the rest are hardware. We're part of the mobile products group within Broadcom. We do all the multimedia that goes into Broadcom's mobile phone chips for their application processors. So we've got our own 3D core and video codecs and display drivers and all that kind of stuff. And also we're the home of the Raspberry Pi apps processor as well, the place with Raspberry Pis. So our little formal initiative there. I guess I came home from last year's event inspired. The good people who talked last year, they convinced me that there was enough potential value for my team in formal tools that we had to go and look. I felt that we were behind the curve, that other companies, some of them our competitors, were further down the road with formal than we were, and they were probably getting advantages, they were probably getting gains that we weren't getting. At that point in time, we'd done very little formal at Broadcom in Cambridge. We'd used it to debug a silicon problem, and that was about it. It was not part of our prime time flow. So I came back, I challenged my team. I've been to this formal thing. We need to do this. And Neo sat down in front here for my team. She stepped up to drive it forward for us. It's been an interesting path. We have done some stuff. Within Broadcom as a whole, there is a company-wide formal initiative that we also got hooked into as well to kind of help us along the way and learn from our colleagues. So what were we trying to do? Doesn't quite look like that on my piece of paper. Anyway, so what we're trying to do, I guess, everybody knows the earlier you find a bug, the cheaper it is. Really, what we do at the moment is mostly UVM, lots and lots and lots and lots of UVM simulations of all our IP, both block level and at IP level. And that's where we find the vast majority of the bugs. Having done that, we then take the design into a crate of FPGAs and give it to the software guys. Software guys run lots of tests on it, and unfortunately they find some bugs as well. And then eventually we take it out to silicon where, because we're perfect, there's never any bugs at all. Yeah, if you believe that. And what we were trying to do with our formal initiative is to try and make these top two disappear. So we want to find everything at this line. Our FPGA is supposed to be a software development platform. That's where our software engineers who are writing our firmware and our drivers, that's where they should be dealing with their problems. They shouldn't be dealing with my problems. If they're having to track down hardware bugs with me, then they're not doing their real job, and that delays our time to market. When we get to the top and it's silicon, that's time when we make our money. That's not time for us to be finding bugs. So what we're trying to do with Formal is take any bugs that we would have found in these top two parts of the triangle and find them down here. Unfortunately, I guess as with a lot of people, our business has invested a fixed amount in verification. There is a certain amount of resource that I have at my disposal as the verification manager to deploy to verify our designs. There isn't any more. I'm not coming at the moment. So if I'm going to adopt Formal down here, I have to find UVM stuff not to do. It's really important to me. I can't do both. I have to look for low-hanging fruit where Formal can be used so I can avoid some UVM. I have to look for places where UVM is not adding as much value. It's a sledgehammer cracker nuts type areas. So that's what I'm looking for. I'm looking for areas that I can go deploy Formal. I can free up my UVM resource to actually go do that. So these are the targets for my initiative. This is what I'm trying to do. So everybody heard about Formal apps. Yeah, really easy to use, nice way of packaging up Formal technology for those who aren't Formal experts to just go do stuff. Yeah, great, really easy, nice and quick. So there's register, proofs versus RTL that we heard talked about from dialogue earlier on. There's dead code analysis and sort of code coverage type angle. There's X propagation apps. There's protocol proof kits. These are all bits of Formal technology that are packaged up as apps that are easy for me to use, and I can go and deploy them, and I can use them to find simple bugs that I don't then have to find in UVM. So this then, if successful, frees up some of my UVM resource to go and write some targeted properties so I can actually go after some of the more complicated things that are really hard to get at in simulation, and I can go and find those bugs. And again, I emphasize in that bullet point there, augment or replace. That's really important. I'm looking for ways to avoid UVM work, to resource this particular activity. Obviously, like everybody, I'm after functional verification utopia where my FPGA is clean hardware bugs before we even get there, and there's no silicon bugs, so I can ship to customers as soon as possible. And also, I'm hoping eventually to be able to sign off appropriate blocks in Formal only. So I decided I'm going to do it. I've decided what I'm going to do. Now I stepped up to drive it. What happened? So we started with the apps. So these apps, easy to use, really quick, really easy. Don't be fooled. They may be easier, but they're not quick, they're not easy. For example, register proof app. So the first thing, maybe I should have anticipated this, but I didn't. The first thing I learned was that I actually need some kind of helper code I have to drive my registers somehow. I have to have a valid protocol there, so I need some helper code to do that. In blocks where we had APP, we could get helper code immediately from the EDA company. That's fine. But when I've got a block that's got my own protocol, there's an internal protocol called RBus that's usually part of Broadcom, and that was on some of our IP, and I haven't got helper code. So there's a barrier immediately there. Some of the standard protocols that do go to registers aren't necessarily supported by your EDA company. The other thing which also hadn't really occurred to me is read-only registers. We have a lot of registers that are used for debug, used for information purposes. So they are reporting status of the internals of our IP. They may be just telling you what a counter is or what a state is or something like that. And the registers are read-only. So when our specification says this register is read-only and this is what it does. Well, the formal tool takes read-only to mean that it's not writable by anything. So this little cloud of logic I've got on the right here that's merrily churning away, coming up with values that my status register is going to observe, makes a right mess of the formal tool. So I have to code around that. Well, this actually is the work that I had to do in UVM land. My UVM register simulation stuff is already able to parse my register description and produce me a lot of automatic tests. The hard work for me is actually dealing with these things. So I've got to deal with these things in formal as well. So did I gain a lot here? I did gain because I have an exhaustive proof. But I didn't gain in terms of workload. So the gain for this is it was perhaps not as much as I thought and I had hoped. The next thing I learned, and this one was very interesting to me. So I'm a verification team manager. I've got 10 people in my team. They're a pretty experienced team. They've got lots of SpecMan knowledge, OVM knowledge, VMM knowledge, UVM knowledge. They've been doing this verification stuff for a long time. And formal is, we've got a lot of good people who use formal in the room today, but it's still not that mainstream of technology. And to me, there must be a reason behind that. But my team were actually really up for this. They were really keen to go deploy formal. Some of them actually went off and deployed a whole load of formal, and I didn't get to know about it till afterwards. I've not been dragging them, kicking and screaming, hey guys, let's go do formal. They've been picking up the tools and going and running with them. And I think that it's because they see this as an additional skill set that they'd like to have. And I think that they see it as an opportunity to reduce some efforts to when they'll be able to get more bang for the buck out of it. The problem I had, I think really is one of sort of methodology. So these people have made a career for 10, 15 years. Some of them, I have a spec, I have a design, I have a certain language, I go do stuff. But moving from that simulation world to doing it in formal is a huge change in mindset. And to my way of thinking, it's equivalent to kind of the jump from directed tests to constrained random. That was a big mindset shift. And I still meet people today who haven't made that shift and would just like to write directed tests for everything. And I think it took a long time for the industry as a whole to actually make that transition from directed to constrained. And if we want to see more formal adopted across the industry and become much more of a mainstream, we need to find ways of helping people to make that change in mindset. And that is the key thing that I'm working with my team to try and do to get us to do more with formal. What else have we learned? So formal tools need a lot of CPU and they need a lot of memory. Anybody want to disagree? No. But what I would say is don't take that on face value either. So we took one of our complicated IPs, we put it in one of the EDA company's tools, and it took about over 100 gig of memory. We'd sat with our friendly AE, and after lots of changing the switches and configurations and things like that, we got down to 16 gigabytes. God, the second one should be bytes, not this, sorry. So it's kind of almost an order of magnitude difference. So in our experience, these tools don't immediately run well out of the box. you need really good support from your AE, from your EDA company to get things going. Now, some of this stuff may well be, those of you who've been doing this a lot longer understand some of this stuff and would have spotted it immediately and sorted it all out. But for us, there was no real clue from the tool. There was no real help, and it really took the effort of the AE to get us through. So if you're going to step more into formal, those of you who sit in the more realistic camp, you want to go do more, make sure you've got really good support from your AE. It's really important, and that will make a big difference to the level of success that you have and the level of adoption within the team. It doesn't help if you're trying to adopt a new technology if you go around crashing the largest machine you have in the department and killing other people's jobs that are running on it. So, you know, get involved with your AE, get these sorted. If you're an EDA company, maybe this is a good way for you to differentiate your tool compared to the others. Maybe this is something that you should be investing your dollars in and trying to make your tool, orchestration was the terminology that Dan used, but, you know, getting a better selection of the engines out of the box for us, so we don't have to think about these things, helping us to analyze whether the memory footprint we're using is actually sensible or not. So that's the main stuff that we've learned. I perhaps should have talked a bit about return on investment at the start when I was setting the initiative targets up, but I decided to leave it till now. So in my team, we've invested quite a bit of effort in this over the last year, learning how to use the tools, trying to learn the methodologies and that. And as with most engineering firms, if not all, you have to justify, I have to justify to my boss what I've done with my resources over the years. So return on investment is an interesting thing that I have to be able to explain to my boss, what have I done with my people and where have I used them, what benefit have I got for the company. This one was a little difficult for us because of where we were in our design cycle. We tend to develop all our IPs in lockstep. They all work together, and we release those to Silicon, and we spend some time supporting them, and we move on to the next generation. And the time when we were attempting to look at the formal tools was towards the end of a development cycle. So most of our IPs had spent 18 months in UVM test benches. They'd spent 6 months on FPGAs. One had actually been test chipped in silicon. So at that point, there's not a lot of bugs to actually find because most of them have already been found using traditional methods. So really what I've been trying to do over the last year is to prepare for the next round. When we do the next round of IP development that will be starting in the next couple of months, then we've got fresh RTL, new designs, new specs. We don't have ready test benches, and that's where we expect to see a much higher return on investment. One of the things I think that we have seen significant return on investment is in those silicon issues that you do get when you don't have great observability or when you have that thing running on an FPGA for 3 days and then the software guy says, actually, it's gone wrong now, and you're trying to figure out what on earth has happened. So at that point, being able to write assertions for the symptoms of the problem and then hone in really quickly on where that problem might be, that's really powerful and really easy to do in a formal tool. So that's something I'm trying to build out. We had a lot of help from the AE to do it the first time. We're trying to build that skill set out over more of us. What tends to happen still at the moment is, oh, heck, I've got to go and try and write a cut-down simulation. And I want to try and change that mindset. So when we have a problem like this, where it's been failing on FPGA for 3 days or in early silicon bring up, to get people to think, right, I'll go write some assertions first. So that's where we have seen return on investment. So if you're at that stage of an IP development, then that is a way to prove a return on investment to your boss. We are not done yet. Our journey, our pragmatic journey into formal is still ongoing. One of the things that I think we're struggling with is understanding where are good places to deploy formal. I think that's something that the user community, the EDA community, I think could help a lot more. More white papers, more examples, that kind of stuff out in the big wide world. And there's plenty of stuff I can Google on UVM. There's less stuff I can Google on formal. So I think that would help get more adoption going. And I think another thing that we're going to tackle fairly soon is this kind of signing off type thing. We have a block that we have done almost exclusively in formal, and we're getting to the point where we're kind of almost done. When we are done with it in formal, we've got to figure out how to sign off on that. So that's something we'll be tackling in the coming months. So Mike's waving at me, so I do need to finish. In conclusion, I think people who are not formal but are verification-minded people are very keen to adopt this technology. If you've got those kind of people, get them some methodology training to bring them up their learning curve. It's not good enough to bring in a company to teach them certain languages. You need a whole lot more than that. Use formal apps. They're great, but they're not as quick and easy as you might think. And work really closely with your EDA supplier, their AEs, to get the tool set up well. Thank you.
Yeah, thank you, Chris. Any questions? Okay.
Hi. So you just mentioned at the end methodology training. I don't know about you, but like you said, if you look for UVM on the web, you find lots of stuff. If you've got some guys who want to do UVM, they can go to your UVM course for probably a week. I haven't come across the methodology training which is beyond assertions of you, to be honest.
I am in the process of organising such a thing with somebody who stood up not very far away from me, but I'm not going to advertise it for him. So there are people who claim to be able to do that. I haven't been on his course yet. I'm not going to give it any certification.
I've got one question as well, Chris. Joking aside, you mentioned before about replacing UVM with formal, and I think that's a very important thing. One thing really the EDA companies just don't quite understand yet. Have you found anything from an EDA company, or any metrics or way of saying if you do formal, you can stop doing this UVM? If you have a good answer to that question.
I haven't from any EDA companies. I find a lot of people don't actually even think about it. I was working with another Broadcom team a little while ago. They had a whole group of people setting up UVM test benches around the thing. They had somebody else trying to prove it in formal, and I said to the lady who's doing the formal, so when can these guys stop doing their UVM? And she looked puzzled at me. Why would they do that? So it's not something that a lot of people are even thinking about.
Maybe it's just me and you being stingy, I don't know.
Well, when I was in S2, that was the question we got from our management all the time. So what don't I do? And actually, a different aspect of that is, as the verification manager, when are you going to feel happy saying this block is good when it's only been through formal?
That's a good question. So we have done a block almost exclusively in formal. It has a simulation test bench, but that was a simplistic one done by the designer. My team has not written a UVM test bench for it. It will be exercised in the FPGA, so I guess we've got backup, and we're using that as a test vehicle. I think we'll be using any coverage metric from formal that we can possibly get our hands on, and sort of stuff that Si was talking about earlier on is certainly of interest to us. At some point, you have to put your neck on the line. So I will go through the assertions with a fine-tooth comb. I'll get them reviewed. We'll take a pragmatic decision and maybe cross our fingers on it.
So I think you partly answered the question of what you don't do if you do formal at the beginning, because you don't do your debug on FPGA and you don't do your debug on silicon. Towards the end, you said there are very few bugs left to find on after the UVM-based verification. Did you actually find any?
We did find some bugs in FPGA. But
did you find any with the formal?
Have we found bugs in that? Yes, we have found a couple of, they were axis protocol issues. We have found a couple of axis protocol issues with formal after the whole time of simulation.
Has that convinced you it's worth persevering with?
It has convinced me that it's well worth persevering with, and I'm currently encouraging my other IPs to go do the same, because only one of them has done it so far. Whether that's enough to convince my boss as well remains to be seen. But yes, I am encouraging my team to adopt more formal. So those of you who came last year would think they'd never hear that.
So follow up on what you said before about your block queue going on formal, you said that you also had a simulation test bench involved design, presumably for bring up, I guess?
So he did that as he was doing the design. So he brought the design up himself.
Right. So what I found, at least some of the designers I work with have found, is actually they find formal very productive for bring up. So it's one of the things which is almost for what you get, it's good value, because you find bugs quickly, bring up, and there's no pressure on closing everything in terms of formal usage.
I guess I understand that point of view, and a number of people have said, well, being the verification team, you're actually driving the formal initiative the wrong way, and your designers need to adopt it first because they'll find the most value in the bring-up stage. I have no power or control over the designers. I do have some level of power and control in my own team. They don't always do what I tell them to do, but they generally do. So that's an area I can make something happen. So that's why I've chosen that route. Some of our designers use embedded assertions, but not very many.
I think I would agree that if you can persuade the designers to write embedded assertions and then generate waveforms of those embedded assertions, and those embedded assertions then become valuable to the verification team. But it's, you have to convince them rather than tell them.
Yeah.
Yeah, so just on the issue of bring up, on the Pelican project at ARM, we've used actually formal exclusively on our memory system units, and the bring up phase was very productive to the point where actually a lot of the time spent with the simulators at the sort of sub-level, so above the unit, let's say a data cache unit, let's say the whole memory system, we have also test benches for the whole memory system, and it was a very long time before actually productive bugs were found using the simulator, because almost most of the bugs have been flushed out by doing unit level form. And these are quite large blocks, so these are like data caches and load store units and so on. So you can be encouraged that you can move that step, and also that the bring up is very productive.
Mm-hmm. Good.
Excellent. Is that an M class or Pelican? Okay, not telling me. Very nice. Suzuka. Any more questions for Chris? Yep, sorry, one last question before break.
Okay, Tom Lee. This follows on from the question earlier. I've been a bit of an outsider here, and I've been very surprised to hear there seemed to be very little structure in the move to verification. Everybody wants to say, well, you just press the button, of course, but there's no theory, and there's very little structure or extra material that's come in. And you'd think that with introducing methods, this would flow back up to the design process, and the whole design would have a way, it would influence the design. It's very surprising not to see that at all. So I wonder if that's just because EDA suppliers are terrified of doing that, or if it's the way design is expressed, or any of that stuff. It's very surprising to see nothing like that at all. So I wonder if you feel like that, or if I've missed something that's going on there.
I think our designers sit in two camps, and there's one that's very giddy and happy, all new tools, new things, and some of those are already adopting formal in their day-to-day lives. And then there's another group that's fairly conservative in their outlook on life, and if they could, they design with schematics rather than RTL. So it depends who you're talking to.
I think Emacs is probably the biggest innovation step, isn't it? Does that count? Okay, so I think we've finished. So thank you very much to Chris.